whenever you are given an identity, the best thing to do is to pick the complicated side, the side which has a lot of things, and reduce it to get the other side. So in this case, the part which has a lot of things is the left-hand side. So we are picking the left-hand side, which is simply the sine 3x. Then this is over sine x. We have cos 3x over cos x. Okay, so we're going to break down the sine 3x into something that looks like this. Sine 3x is the same as sine 2x plus x, using the double angle formulas, where this is like your A, this is your B. Remember that formula that says sine A plus B, right, is equal to what? Sine A, then cos B, then you have plus sine B cos A. It's the same thing here. We're going to have sine 2x, then cos x, then plus sine x and cos 2x. That's us trying to break down the 3x, the sine 3x. Then we go a step further to break down this double angle. This is still a double angle. This is going to give us 2. Remember, sine 2x is the same as 2 sine x cos x, right? Multiplying this other cos there. So that's a cos. Then plus, there's a sine x cos 2x. According to your double angles, this is just the same as cos squared x, then minus this. So in short, we're just saying the sine of 3x is the same as 2 sine x, cos times cos, that's basically cos squared x, plus sine x and cos squared, then minus sine to the power 3, which is the same as this, plus this will give us a 3, because they're like terms. 3 sine of x and cos squared of x minus sine cubed of x. So this is what we have. This is the sine 3x. This is what we have. So now we're not yet done. We're just getting the simplified version of the first top part. So wherever there is sine 3x, we're going to replace with this expression here. So we're just trying to break down the sine 3x. This is what we get. Yeah, so hope you're okay to see that this is, they're like terms, not that we're adding them. So we've just broken down the top guy, this part here. That's what we have done. We'll also do the same for the cos 3x. So we're supposed to have an expression for cos 3x. This is a triple angle, so this is going to be cos 2x plus x. This becomes cos 2x, cos x. Remember the rule for cos A plus B, right? That's the one that we're using. This will be sine 2x and sine x. We know what this is. This is the same as cos squared x minus sine squared. This is being multiplied by cos x. There's a cos x there. Then this is simply 2 sine x and cos x. We're multiplying it with this sine x there. This will just be cos to the power 3 x, then minus. This is simply going to be cos x, then sine squared, minus. This is 2 sine squared and a cos. This here will just end up being, we're having cos to the power 3 x. This will be negative 3 cos x and sine squared, because these two are like terms. So now we've simplified the expression, so we can now do the replacements. We're saying where there was sine 3x, we're going to replace this. Where the sine 3x, we are replacing this guy here, which is 3 sine x cos squared x minus, this is sine to the power 3, so negative, this is sine to the power 3x. Then down we had a sine, right? This is what you had. Minus, for this cos 3x, we got this, so this is just going to be cos, then 3 cos x, then you have sine squared x. This here is divided, being divided by the cos. Then from here, we notice that on top there's something common, right, which is the sine. We can factorize the sine on top, one sine on top, so we'll have 3 cos to the power 2x minus a sine squared over a sine down minus, on top we can factorize a cos. What remains is cos squared minus 3 sine squared. Then there's a cos here. So this cos and this cos cancel, this sine and this sine cancel, meaning we're just remaining with 3. This is 3 cos squared x, then minus sine squared x. The negative affects everything this side. This will be this, and then this will be plus 3 sine squared. So the like terms here, there is this 3 cos squared minus cos squared. That's going to give us 2 cos squared. Then this will also give us 2 sine squared, because these are like terms as well. Then here we're simply going to factorize a 2. We are simply going to remain with a sine squared plus a cos squared. We know that this is a 1 according to the identities, so 2 by 1. This is what gives us the 2, which happens to be the right hand side. Hence proved. This is basically the proof.